Okay, so this is a replacement video to measure voltage on a Voltcraft oscilloscope. So you see we've got an oscilloscope there. I'm going to take this auto set control off first. And we're going to look at how you would measure voltage on an oscilloscope. I'm maybe going to change the amplitude of that a wee bit. Make it something a wee bit simpler to start with. Okay, so I'm going to talk about these controls in a wee minute. So, the first one we have here, so here we have our waveform. Pop that off just now. Take that off just now. So down here you'll see a number which is 1 volt. That means that every one of these big boxes here is worth 1 volt. So if you were talking about this waveform, you would describe it as either being 2 volts peak, as in 1, 2, or 4 volts peak to peak. So going from the bottom to the top, 1, 2, 3, 4 boxes, each one being 1 volt. You can use this connector here, this dial, to change the volts per division. So there, that's taking you to half a volt a division. So now you'd see that each box is worth a half, so it'd go a half, 1, 1.5, 2, 2.5, 3, 3.5, 4, and it's just over the 4, isn't it? Just over the 4. You can go the other way. That's you now in 2 volts a division. So each one of these boxes is worth 2 now. So going from there to there, that's 2 volts, and going from there to there, that's 4 volts. So 2 volts peak, 4 volts peak to peak. And we're using this volts per division setting to change this scale, but what you're measuring doesn't change at all. It's just a scale. So if I go back onto 1 volt a division, I can use this wee button here. I can use this to either change the position like that, up and down, or if I press it, it should centre it. But it centres it on where that arrow is. So I might still want to do a fine adjustment on that. Okay. Also, this scope has got the facility to measure, using that button there. So here it tells me my peak to peak, 4.24 volts, 4.20 volts. And that's your peak to peak setting there. You can switch that back off again using this, and that would be your voltage there. Using that, you can also use this peak value here of 4 volts to work out the RMS. Because to get the RMS, you do 0.707 times that 2. So 0.707 times 2 will get you 1.414, and that will be the RMS value for this. And for the average, you do 0.637 times 2. 2 is the peak value. So you do 0.707 times the peak to get RMS, 0.637 times the peak to get your average. Your peak is from that centre line to the top, and your peak to peak is from that top line to the bottom line. So these are all measurements you're taking kind of up and down the way in this vertical. So if I now change this and make it something totally different, that I can't really see at all, there are 2 ways you can either adjust this. You can adjust it using this connector here. This one here changes your time base, which is this number here, which is kind of your horizontal setting. And use this one again to get your volts per division. Okay, so your volts per division is now something you can see. And you can also do that with your time base. So there are these 2 you would use to adjust. Similarly, if this was a signal you couldn't see, you can use auto set on this scope. And auto set should put it into 1 or 2 waves on the screen and something that you can kind of easily read. You're on 5 volts a division there. I'm going to take that off. So your peak value there is just over 10. You'd maybe say that was about 11. Peak to peak, 22. Your RMS would be 10 times or 11 times 0.707. And your average would be 11 times 0.637. This scope again will measure it. So your peak to peak, we thought about 22, 21.8. So 21.8 is your minimum, your peak to peak from here to here. Let's change it again, let's go the other way and make it something that's quite small. So again, you would use this and this to set on that. Altitude about there. And you can use auto set or you can use these connectors again. So there you can see the wave coming in as I'm adjusting this time-based setting. It looks as if it's going to be too big, so I'm going to change my scale from being 50 up the way. So 50 a box isn't letting me see it. Would 100 a box? No. 200, 500, 1 volt per division, nearly. 2 volts per division. Let's move this time base in again. There we are. 1 volt a division. So I can see it on 1 volt a division. So I'd centre that again using this vertical to move it up or down. And then kind of looking at this, I'd be trying to get something centred so I've got as much above the line as below the line. So from the midline to the top, each one of these boxes is worth 1 volt. So it's 1 volt to here, and then it's not a full volt. I'm going to move this sideways using this controller here. If it will move. And see if I can get it to sit on the crosshair so I can make quite a good estimation of how much I think it is. Not all oscilloscopes have the facility where you can measure. So I think that's not 1 volt, 1.2, 1.4. I would say just over 1.4 if I was saying peak. So about 1.4 peak, which is about 2.8 peak to peak. 2.96 is what the scope's measuring as, peak to peak. So that must be nearer 1.5 than 1.4. And in the next video, it shows you how to use the time base, which is this kind of section over here, to work out your periodic time and therefore your frequency.